Okay, so number 20 on the quiz. So we say that we want to find the value of x over, or excuse me, the limit as x goes to 1/2 on the right of x over 2x minus 1. Now we know that we can't use direct substitution, because if we were to use direct substitution, we would get 2 times 1/2, which is 1, minus 1, which is 0. So what we can do is we can do a little bit of reasoning. So if x is a number that's slightly greater than 1/2, right? So we have x greater than 1/2. Then if we multiply both sides of this by 2, then we get that 2x is going to be greater than 1. If we subtract 1 from both sides of this inequality, we know that 2x minus 1 is going to be a value that is greater than 0. Another thing that you can use is maybe some test points and throw them in there and say find a value of x greater than 1/2, let's say maybe 3/4, and put it in there, and what you would find is that you would get a positive value, right? So in the denominator we have a positive value. In the numerator, because x is greater than 1/2, clearly we also there have a value which is greater than 0. So we know that there's going to be a vertical asymptote because we get division by 0 and there's no cancellations, right, between the numerator and the denominator. So the function diverges, and it diverges either to positive infinity or to negative infinity. But if we know that all the signs are going to be positive in the numerator, and all the signs are going to be positive in the denominator, then we get a positive value divided by a positive value, which is going to become a positive value. So that means that it has to diverge to positive infinity. And that's what we say. And that's the answer to that question. So next question is number 21. It says find the one-sided limit, state as infinity where appropriate. So we have the quantity of x squared minus 2x plus 1. We factor the numerator, and it gives us x minus 1 times x minus 1. And that's what the numerator factors into. Unfortunately, no cancellations. So there's no factors which are in common between the numerator and the denominator. So that means that if we approach -1, we will always get a value which is 0 in the denominator, because there are no cancellations. So it's non-removable discontinuity. So we know that it diverges. There's a vertical asymptote at x equal to -1. So we just have to determine whether or not it diverges up or it diverges down. So if x is less than -1, then we know that if we subtract 1 from both sides of this inequality, then we know that x minus 1 is going to be less than -2. Which means that x minus 1 is going to be negative, right? And another way to say that is, all right, well, let me try a test point in here. -2 minus 1, so that's -3. So clearly, all these values are going to be negative. X minus 1 is going to be negative. If we add 1 to both sides of this inequality, we get x plus 1, but that's still going to be less than 0, right? So all of these quantities that are here are all going to be negative. So let's try to determine what the sign becomes in the end. So we have a negative quantity, right? And we're multiplying that to a negative quantity, and it's going to be divided by a negative quantity. And we just used our little operations of knowing that a positive and a negative are a positive and a negative become a negative and a negative become positive, etc. So that tells us that we're going to have the top is going to be negative times negative, so that's going to be some positive number, and it's going to be divided by a negative number. So in the end, we are going to get a negative number. So that means that if it diverges either up or down, so that means that it's going to diverge down, so we get negative infinity as the limit. So that means that the limit does not exist, but we're giving us a little bit of information of what it does and why it doesn't exist. So, all right, so number 22. So, you do have to write this, right? You have to write the limit as x goes to -1 on the left is negative infinity. Okay. So, in number 22, we have identified the vertical asymptotes using the limit process, show the limits from the left and right. Okay, so you have to identify where the vertical asymptotes are. So first thing that we do is factor this quantity. 4 minus x squared is a difference of perfect squares, right? The first perfect square is 2 squared. The next perfect square is x squared. So we can rewrite this as 2 minus x times 2 plus x. See, there are no cancellations between the numerator and the denominator, so that means that there's going to be vertical asymptotes at x equals plus and minus 2. And it's continuous everywhere else. So that means that we divide up our region into, we divide things up into individual regions. Or excuse me, 4 individual regions, right? One of them is going to be for x less than negative 2. The other region is going to become between negative 2 and 0, because we're trying to identify all the places where all the signs have to remain the same. So the other thing that we note, besides where the vertical asymptotes are, where there are no cancellations and the function has to be discontinuous, is that the function has to be continuous at every other point besides negative 2 and plus 2. So that means that we can identify where the function is equal to 0, right? And then at all the other places, it has to either stay below 0 or above 0, or it has to switch from between negative to positive, but only at these discontinuities, right? So it's allowed to switch wherever it's discontinuous also. So f of x equals 0 only when the numerator is equal to 0. So that means that it's only equal to 0 at x equal to 0. So our first region is for x less than negative 2. Our second region is between negative 2 and 0. Our third region is between 0 and 2, and our fourth region is greater than 2. And we're trying to identify what the function does as it approaches values equal to x equal to negative 2 and x equal to 2. So in our first region, if x is less than negative 2, then our numerator, if it's less than negative 2, means that our numerator is going to be negative. Our denominator is going to be positive, right? Or excuse me, negative. And one of the reasons for that is that if x is less than negative 2, we're going to get 2 minus some quantity which is less than negative 2. So it's going to be negative. So we get 2 minus a negative number, which is a positive number. So this first quantity is going to become positive. The next is going to be 2 minus a number which is less than 2. So clearly this quantity is going to be negative. And 4 times a negative number is going to be a negative number. So we get negative over positive times negative, which is going to give us positive. So that means that the limit as x approaches negative 2 on the left of f of x is going to be positive infinity, right? So it's going to diverge up as we get closer and closer to negative 2. So our second region means that we are between negative 2 and 0. So if we're between negative 2 and 0, we still have numbers which are negative, so our numerator, 4 times x, is still going to be negative. Our denominator this time is going to be 2 minus a number that's between 0 and negative 2. So that's definitely going to be positive, right? Because we get minus a negative number, which is a positive number. Still the same reasoning as the last time. But here we get 2 minus, or 2 plus a negative, which is the same thing as 2 minus a number between 0 and 2. So this quantity is going to be positive because we're not subtracting, we're not more in magnitude in terms of the first number and the second number. So I'm taking 2 and I'm taking away a number which is less than 2. So this quantity is going to remain positive, right? So in that case, we get a negative over a positive times a positive, so it's a negative over a positive, which is negative. So the limit as x goes to negative 2 on the right is going to diverge downward. Right? Okay. So that's the second region, and the third and fourth regions have reasonings which are very similar. So, The limit as x goes to 2 on the left is going to be positive infinity. The limit as x goes to 2 on the right is going to be negative infinity. Okay? All right. Last two questions, 23 and 24. Here we have to know that the limit as x goes to 0 of 1 minus cosine of theta over theta is equal to 0. And we have to know that from class and our lecture. The two that we had gone over, remember, was sine of x over x and 1 minus cosine of x divided by x. And those were the two limits that we had looked at in class. So using this fact, we can look at this and we can say, all right, well, let me factor out a 3 from the numerator of this expression, and I get back to this limit. So if I know that the limit exists of two separate things as some quantity approaches some point, then I can substitute that value. I know that the limit of two things which are multiplied together will be equal to their limits, the value of their finite limits multiplied if they exist. And we know that 1 minus cosine of theta over theta approaches 0 as theta goes to 0, and the limit as theta goes to 0 of 3 is still just 3. So when we use that substitution there, we get 3 times 0, so the limit of this quantity is equal to 0. The next problem, we just have to get it to a point where it looks like 1 minus cosine of theta over theta. So cotangent here is the same thing as cosine of theta over sine of theta. And if you had known that, then you could have seen that the sine of thetas easily cancel, and we get only left with cosine of theta there. So it becomes 1 minus cosine of theta over theta, and this goes to 0. So the limit of this is equal to 0. And that is the quiz. Okay. If you have any questions, you can email address provided in class, and I will get back to you as soon as possible. Okay?